Hello students and welcome back to Diksha Karnataka YouTube channel, and you are watching KCET 60 out of 60 in physics series. Today is going to be the last lecture of the all chapters. Second few chapters are already over. You can check all the lectures of second few chapters in our channel. The link is given in the description where it is mentioned physics playlist. You can check all the physics lectures from there. Today I am going to discuss the last chapter of your first few chapters are also completed, right? So waves is going to be our last chapter. This will going to be the complete chapter plus PYQs based on KCET important topics only. I am not going to discuss the entire chapter to burden you. You should know what all are important for your KCET. Only those portions I am going to discuss. Okay, now also if you are watching this video for the first time, the link of this entire playlist is given in the description. You can check there. Also you can join our WhatsApp channel. The link is given in the description as well. Join our WhatsApp channel whenever we are doing something new. Some crazy updates are coming. We are updating that in our WhatsApp channel. All the Sunday question paper is coming in our channel, so everything is available in our channel. Join there without any delay, without wasting time. So without wasting your time, let me start with the today's chapter. First of all, let us look into the topics. We will learn about types of waves. There are two types of waves, then equation of waves, basic general equation of waves, then speed of sound, then we will learn about standing wave, then we will learn about stress string, and lastly organ pipe. So the chapter will be over. Okay, and I am not going to discuss about entire theory. I am only going to discuss, if anything, any important theory part is there and the formulas. Okay, this chapter, from this chapter most the question comes from based on the formula. So first of all, there are two types of waves. Transverse wave, the oscillations are normal to the direction of wave motion along the string. So if the oscillations are normal to the motion of the string, so now wave, we know that waves are basically transfer of energy from one point to another point without disturbing without displacement of the medium, right? Without actual displacement of the medium, if energy is getting transferred from one point to another, then we call it as a wave. So for example, there are many types of waves. Light waves, okay, light, there are a huge spectrum of light. We will learn that in electromagnetic wave. We already learned that, right? So light is a huge spectrum of waves. Okay, it's an electromagnetic wave. Then we have sound wave. Sound wave is also a form of energy which is transferred from one point to another. And we also have heat wave, radiation of heat, which is also form a wave, right? Now wave transfers in two ways. One is this is called transverse wave. Basically whenever we draw a wave, we generally represent this, right? Another way is longitudinal wave. So longitudinal wave is like this, like this. If you play using a slinky means the this spirally thing, you may have seen that. Okay, so this is where you see that the medium is concentrated. Here it is separated quite a lot, then again it is concentrated. Okay, so this is called concentration, this is called radification. You have learned that in your previous classes, I hope so. Okay, so, sound transfer of sound. Okay, so there you have learned that sound transfers like this. Okay, at some places it is concentrated, some places it is distributed rapidly. Okay, and if you have not done, you have learned in your first few class as well. Theory part I am not going to discuss. As I said, in longitudinal wave, the oscillations are parallel to the direction of wave. So in this case, wave is getting transferred in this wave. These particles are also oscillating in this direction. In this case, the particle is oscillating in up and down direction, whereas wave is propagating in this direction. Okay, most of our known waves are transverse wave. Okay, sound, not sound, light, okay, heat, all the radiations, they are basically transverse wave. But where we are talking about sound wave, they are longitudinal in nature. Okay, any physical wave or mechanical wave, when they transfer only using longitudinal wave. Okay, now let's move on to the equation of waves. Equation of wave is basically given by y xt equals to a sine kx plus omega t plus phi. Okay, here this part is important, this part you can omit. This is the phase difference, this is the phase difference. So what is the meaning of the phase difference? Generally, if phi is 0, the graph will be always like this. Okay, now if the phase is pi by 2, then the graph will be like this. Okay, if the phase is anything else other than pi by 2 and 90 degree or between 90 and 0 degree, so it will be somewhat like this. So based on the initial phase, this determines the initial phase. Okay, how the wave, from where the wave is actually starting. Okay, so based on where the wave is actually starting, you can have this phi. Generally, most commonly phi is considered to be 0, so this is a pure sine wave. It is a cos wave. For cos wave, phi is pi by 2, but we do not change the sign here. Okay, this is always fixed, sine kx plus omega t. Okay, you have to remember that this is fixed, and this is obviously initial phase angle. This term k is equal to 2 pi by lambda is called wave number. Okay, this has a physical meaning. I am not going into detail of the physical meaning of this, but if some equation is given, for example, if I give you y is equal to say 5 sine 2x minus 5t. Okay, suppose I give you some equation like this. From there you see that, okay, this is the k value is 2, and this is the omega value is 5. Okay, so using this you can calculate the wavelength. Okay, wavelength you can calculate. 2 pi by lambda is wave number, so lambda 2 pi by lambda is equal to 2, so lambda equals to 2 pi by 2 is equal to pi meters. They will give you some unit. Okay, in that unit you can calculate the wavelength. Okay, so that is why this wave number is important. You can calculate wavelength using this value wave number. Next is velocity of the wave. This is very important. Velocity of the wave. Velocity of the wave, from the equation of wave you can say this is omega by k or lambda by t. T is the time period. Whichever formula you can remember. This is easy to remember because you get k from here, omega from here. So omega by k is the velocity of the sound wave. Okay, now speed of sound in medium. Okay, speed of sound, as you know, Laplace correction is correct sound. Speed of sound is gamma p by rho. Okay, gamma p by rho part we already know. Now if you multiply v both side, in the numerator and in denominator, then you get PV in the numerator and rho V in the denominator. What is the meaning of rho? Rho is here density, right? So rho is basically mass by volume. So mass of the gas is rho times volume. So if the volume of the gas is enclosed, okay, then this rho V actually mass of the gas. Right, rho V is the mass of the gas, and PV is equal to RT for 1 mole gas. We know that ideal gas, so PV we can write it as RT. So for the in terms of gas temperature and mass of the gas, we can write speed of sound in a medium with respect to temperature is gamma RT by M. Now RMS speed of a gas, we know that is given by 3 RT by M. Right, so RMS speed is given by 3 RT by M. We already derived that, if you remember, and then you can find the ratio of V by VRMS. This is very, very important relationship. V by VRMS is gamma by 3. Okay, this is a constant and it depends on the gamma. What is gamma? Gamma is Cp by Cv. Right, gamma is Cp by Cv. Based on what type of gas you are using, you can calculate the ratio of V by VRMS. This question not only comes in KCET, based on this formula, questions also come in JEE mains exam, okay, in NEET exam as well. So you have to remember this formula. This is very, very important formula from this chapter. Okay, they try to test you whether you know the relationship or not. So it is very important. Now standing wave. Equation of standing wave is given by xt is equal to 2a cos omega phi by 2 sine kx minus omega t plus phi by 2. So as you can see, this is an equation of standing wave. Okay, There is another form, we will discuss that during solving our PYQs, but this is one of the common form of standing wave. What is the meaning of standing wave? Standing wave is one wave is coming from this side, okay, another wave is coming from other side. When they superimpose on each other, they have the same amplitude. Obviously, equation in wave equation also, in oscillation also, this term A represents the amplitude, right? So same amplitude is same here as well in waves and oscillation. Okay, so as you see, so two waves of equal amplitude but slightly different in phase. The original phase difference is phi. When they superimpose, they form a wave like this. Okay, and in fact, you can say that y is equals to A cos kx sine omega t by 2, right? So this is the equation of wave. This is wrong. In fact, that can be said that it is sine kx into cos omega t. Okay, so this is also equation. Actually, this is the equation of standing wave. So as you can see in the standing wave, there is no relationship between x and omega t. So wave does not propagate when they are actually having the equal amplitude. They superimpose and they produce an oscillation. Okay, so the medium starts oscillating, but there is no progress of the wave. That's why it is called a standing wave. Okay, standing wave means it is not propagating. Wave means progressive, right? So progressive means it is propagating. So there is a omega t term, there is a kx term, but when they superimpose, they give you equation like this. So as you can see, only sine is left with kx term and cos with left with the omega t term. So they actually superimpose and cancel each other. Okay, now this is a stretched string. Stretched string means you have a string. Okay, you have played this in your childhood, I am sure about that. You tie the string between 2 points and then you pluck it, so it starts vibrating. If you play guitar or if you play any wired instrument, violin or etc., then basically this is nothing but this stretched string. They are all type of stretched string. So what happens when you stretch at the middle? Okay, it starts vibrating like this. This is called the fundamental or first harmonic. This is the fundamental frequency. So in a guitar, when you take a string and pluck it at the middle of the guitar, that is the smallest frequency of the guitar. Okay, that is the fundamental or first harmonic of the string. Now if the length, there is a relationship between length. If the length of the string is say L, okay, now as you can see, if this is a wave, okay, if this is a wave, you know that this is basically, this entire thing is starting from here to here is lambda. This is one wavelength, right? Here it is basically producing a standing wave. Now in standing wave, if such one wave from the other side comes like that, okay, then they will produce this stretched string. Now you can see that here only up to this much is available. Only this much is available. So what is this distance? This distance is lambda by 2. This you have to remember that if there is middle, in the middle, if there are only one maximum, then this distance is lambda by 2. So from here you can say that L is equals to lambda by 2. Okay, or lambda is equal to 2L. Now speed of sound in a medium is given by V is equal to n lambda, or speed of sound, you can say that frequency is V by lambda, or it is V by 2L. Okay, you can calculate the frequency for individual cases. As you see, the wavelength increases. Here the wavelength is, suppose this wavelength is fundamental frequency's wavelength is lambda 1, this is lambda 2, this is lambda 3, this is lambda 4. Each of them has different lambdas and each of them has different frequencies. So this, in this case, this is n1 lambda 1. Okay, so but L will be fixed. L will be fixed. So every frequency you can calculate in terms of this L. Okay, and you can calculate the corresponding frequency. Okay, this is the fundamental frequency, this is the second harmonic, this is the third harmonic, this is the fourth harmonic. Now you can see in this case how many, so this is lambda, suppose 2 by 2, this is lambda 2 by 2, so total wavelength is lambda 2. Here also lambda 3 by 2, lambda 3 by 2, here also lambda 3 by 2. So in how many kinks are happening, based on that you can find the wavelength of the produced wave. Now you should remember that this term where the maximum displacement is happening is called antinode. Okay, and here where minimum displacement is happening, this is called node. Okay, so here this N represents node, A represents antinode. Also what you have to remember that when there is no point to displacement, there should be definitely node. Okay, and where there is maximum possibility of vibration, there will be antinode. Okay, now as you see in this case these 2 points are fixed, so always there will be nodes. There will be nodes in these 2 points. Antinodes can happen anywhere in the middle. Okay, you can find n number of combinations, that does not matter, but there will be always nodes at the end. Nodes will always be at the end. I will give you one more example, the next part, which is organ pipe. As you can see in this case, this point and this point and this point, here it is a closed pipe where one end is closed, so you are blowing air on one side is closed. If you blow air like this, okay, so this is a one-sided closed organ pipe. Okay, and in this case there will be definitely a node here, and here this side is open, so this side here will always be antinode. This is fixed, these 2 points are fixed. In case of organ pipe, this will always be antinode, this will always be nodes. Any other position is possible in between. So as you can see, in case of closed organ pipe, not all the harmonics are present. This is fundamental harmonic, this is third harmonic, this is fifth harmonic, so only odd number of harmonics are present in case of organ pipe. Okay, now in case of both side opened organ pipe, that is like your normal flute. Okay, where both sides are open. There is a type of flute where one side is closed, but we so that is basically this one-sided closed organ pipe, and there is a normal flute where both sides are open. So in this case, this is the you can see fundamental, second, third, fourth, all harmonics are present. Okay, so because all harmonics are present, sounds you hear better quality sound. That's why normal flutes are made up of both sided open pipe, but this sound has a specific kind of sound, so some specific designs also have this kind of flute as well. Now I don't know if you play flute or not. If you play flute, don't forget to mention that in the comment below, sir, I play flute. Okay, what type of flute you play, that also you mention. Okay, now you can see that based on what is that, this is fundamental frequency. So I told you in the previous case, if you see something like this, then there will be lambda by 2 distance, right? So lambda by 2, fundamental is, if it is fundamental, lambda 1, if it is second order, lambda 2, if it is third order, lambda 3, like that. Now in this case you don't see this complete bulge, right? So in this case you don't see this complete bulge, instead you see only half of that. So this distance I told you, this is lambda by 2. So what is this distance? This distance is lambda by 4. So basically for one end open pipe, this distance is lambda 1 by 4. Okay, you have to remember that. Okay, this is lambda by 2 for one-ended open pipe. Okay, one-ended closed pipe, basically this is lambda 1 by 4. So this is lambda 2 by 4, lambda 3 by 4, sorry, and this is lambda 3 by 2. Okay, so you have to add these to get the total wavelength. In this case, lambda 5 by 4. Right, lambda 5 by 4, it is lambda 5 by 2, lambda 5 by 2. So these are all the possible harmonics. In this case, this is lambda 1 by 2, 1 by 4, lambda 1 by 4. So basically if you add them, you will get lambda by 1 by 2. Okay, and similarly if you add them, you will get lambda 2 here. It is lambda lambda 2 here. You will get third harmonic, so lambda 2, lambda by 2, lambda by 2, lambda by 2, so it will be 3 lambda by 2. Okay, so you will get all the harmonics. Basically harmonics means multiple of this. Fourth harmonic means 4 lambda by 2. So if you get lambda 2 will be basically 2 lambda 1 by 2. Right, so basically twice of the initial fundamental frequency. So most higher order you are getting the multiplier of the fundamental frequency, fundamental wavelength. Okay, that's why it is called harmonic. Okay, that is why it is called harmonic. You should remember that. Now let's look into the PYQs from this chapter. First question is based on the concept of RMS speed. The speed of sound in ideal gas at a given temperature T is V. The RMS speed of the gas molecules at that temperature is Vrms. The ratio of the velocities of V and Vrms for helium and oxygen gases X and X dash respectively, then X by X dash is equal to, so V by Vrms, we already know that is nothing but gamma by 3. Okay, now for oxygen suppose this is X. Okay, no, so for helium suppose it is given X, so this is helium. Okay, and for oxygen it is X dash, so for X dash we know that this is nothing but gamma oxygen by 3. Okay, why I am doing that? You would actually don't need this V by Vrms, only the formula is sufficient. Okay, now they have asked you to find X by X dash. So if you are finding X by X dash, you can simply cancel whatever constants are there. So X by X dash equals to gamma helium by gamma oxygen. Now you should remember that helium is a monoatomic gas. Okay, for monoatomic gas gamma is 5 by 3. Okay, and oxygen is a diatomic gas, so for oxygen it is 7 by 5. Okay, so more number of orders you go, 5 by 3 is the starting point. For higher order you have to add 2 here, 2 here. Okay, you remember 5 by 3. Then for this is for monoatomic. For diatomic it is 5 plus 2 by 3 plus 2. Okay, 7 by 5. For triatomic 7 plus 2 divided by 5 plus 2. If you remember like that, you will always remember the final value. Okay, so this is how we should remember. Now we have to find the ratio of these two. Okay, so ratio of these two, put the values. Five by 3 divided by 7 by 5. I hope I am doing it correctly. For helium and oxygen X and X dash. Okay, now it will be square root of 5. This 5 was in division, it will go up, divided by 3 times 7, so it will be 5 by square root of 21. 5 times 5 is 25, square root of 25 is 5, and in division square root of 3 times 7, that is 21. So 5 by square root of 21 is the answer. Okay, next question. To propagate both longitudinal and transverse waves, a material must have bulk and shear moduli, only bulk modulus. Okay, only shear modulus, Young's and bulk modulus. Okay, so you should remember that when you are extending a wave, okay, you must have bulk modulus for a longitudinal wave. Okay, but for transverse wave, Young's modulus is important. So basically Young's and bulk modulus both are important, for because when you are extending it, stretching it, okay, Young's modulus is really important. So both transverse and longitudinal for mechanical wave, you have to have Young's and bulk modulus. Okay. Now the equation of stationary wave is y is equal to 2 sin pi x by 15 times cos 48 pi t. The distance between a node and its next antinode is. So first of all, what we will do, equation of standing wave is given. Okay, so equation of standing wave is given. We know that y equals to a sin kx cos omega t. Okay, this is the equation of standard equation of standing wave. From comparison, we can say k is basically pi by 15. Okay, k is pi by 15 and omega is 48 pi. Okay, now what we have to do, we have to find the wavelength. Wavelength is 2 pi by k. K is 2 pi by lambda, so lambda is 2 pi by k. So basically 2 pi divided by pi by 15. Okay, or lambda is 30. So we have calculated lambda. Now we are trying to find the equivalent of the wavelength. Okay, now in this case this is not clear whether what type of stationary wave it is. Okay, minimum possible distance, the minimum, they should have either mentioned minimum possible distance, or they should have mentioned what type of motion it is. If it is an open pipe, there will be something. If it is a closed pipe, the distance will be different. If it is a straight string, the distance will be different. But the minimum distance happens only for one end closed pipe, right? In that case, the minimum distance is x equals to lambda by 4. That is the fundamental frequency. In case of straight string, it is lambda by 2. In case of both sided open pipe, it is also lambda by 2. But we are finding the minimum possible value, nothing is mentioned. So you can expect this question, I think, will be a bonus question if nothing is mentioned. So 30 by 4, so it will be 7.5. 7.5 is the unit. Okay, but on the given option, they have not even considered 15 as the answer. So only 7.5 units can be answered from the given options. So that is one factor as well. So they might say, okay, from the given option only lambda by 4 is coming, lambda by 2 is not at all coming. So obviously this is the answer. You can check x equals to lambda by 2 as well. Then in that case it will be 30 by 2, which is 15. Only two possible cases of fundamental frequency, fundamental distance, that is minimum distance. Okay, so distance between node and next antinode, node and antinode. One more thing, sorry, they have said node and antinode. That is very important. Node and antinode means this value, right? My mistake. Node and antinode is always at a distance lambda by 4. Node and antinode is always at a distance lambda by 4. Sorry. So lambda by 4 will be only the answer. Lambda by 2 it will not come at all. Sorry, I was thinking the fundamental wavelength. Fundamental wavelength, they have to mention the process. But node and antinode will always be lambda by 4. No matter what instrument, what process you are using, it will always be lambda by 4. First overtone frequency of a closed pipe of length L1 is equals to the second harmonic frequency of an open pipe of length L1, so L2, sorry. Okay, then the ratio of L1 by L2 equals to, first we have a closed pipe, okay, of length L1. So what is the closed pipe? One side closed, obviously closed means one side closed. So first one side closed, we have this is the first case. Okay, this is the first case. For fundamental frequency, say lambda naught. Okay, so this is say lambda naught, and we know that this distance, if this distance is L1, then this is lambda naught by 4. Okay, lambda naught by 4. So here the first overtone is the second thing. For closed pipe, the first overtone is given by L1 3V by first overtone F1, 3V by 4 F1. Okay, so here F1 equals to 3V by 4. Okay, and for open pipe, the first harmonic, second harmonic is given by for open pipe. Open pipe, we know this is the open pipe, so this is slightly different. You can learn these formulas in your P1. So L2 is basically V by F, right? V by F2. So F2 equals to V by L2. Now by formula they have given, this is the formula. Okay, this is the formula. So F1 equals to F2. You can use N1, N2. I am using F1, F2. Nu 1, Nu 2, all are fine. Okay, so 3V by 4. Okay, L1, 3V by 4 L1 equals to V by L2. V cancels, this will go in this side, so 3 by 4 equals to L1 by L2. Okay, so 3 by 4 is the answer for this given question. This is slightly complicated, old-fashioned questions. Okay, also some questions are based on Doppler effect, which are now deleted. So that's why, as you can see, some of the years are skipped. In fact, 2024 questions also based on Doppler effect. Doppler effect is no longer part of a syllabus. If you see any questions based on Doppler effect, you can skip that. It is not part of the KCET syllabus. Okay, the waves set up in a closed pipe are longitudinal and progressive, longitudinal and stationary, transverse and stationary, transverse and progressive. Waves set up in a closed pipe are definitely longitudinal and they are stationary. Okay, closed pipes are always stationary. Okay, and they are longitudinal. In string, in case of a string, okay, they are transverse and stationary. Okay, if you have a string tied up like this, so for example, if your home has cloth drying ropes, okay, they have cloth drying ropes. Modern day cloth drying ropes are, there are a lot of different ways, but in old fashioned way we used to hang our clothes in the rack, maybe near our balcony, maybe near rooftops. But nowadays there are racks, etc. are coming. But if you have old fashioned ropes, then we used to play with those ropes. Okay, we used to play like the strings, right? Some of you can relate that, and that is basically a transverse wave, and that is also a stationary wave because it is not moving anywhere. Next is question number 6. When two tuning forks A and B are sounded together, 4 beats per second are heard. So beats is very small concept. I have not included in my discussion, but I will explain it in this problem. 4 beats per second are heard. The frequency of the fork B is 384 Hz. When one prongs of the fork A is filled and sounded with B, the beat frequency increases. Then the frequency of the fork A is. So first of all, beat frequency increases. Beat frequency is nothing but difference in the frequency. Beat frequency is nothing but difference in the frequency. Now F1 minus F2. So what is the possible if frequency of the fork B is given 384? Okay, so frequency of fork B is given 384. Okay, so the frequency of fork A can either be 388 or it can be 380. Both are possible. 388 and 380 both are possible because in this both cases the difference is 4. both cases difference is 4. Now what is they are saying, when one of the prongs of the fork A is filled and sounded with B, the beat frequency increases. Beat frequency increases means when you fill one end of the fork, okay, its frequency basically decreases. Okay, its frequency decreases, and its frequency decreasing means it will have a lesser frequency. Okay, if you make it bulkier, if you make it heavier, its frequency will decrease. My mistake, when you fill up the one of the prongs, its frequency increases. So frequency increases means if 380 is to be the true answer, then its frequency increases means it will, suppose now new frequency is 381. Now as you can see, the beat frequency would have been 3 Hz. So it is decreasing. So as the frequency increases, the frequency is decreasing in this case. So only possible case where frequency would have been, the beat frequency will increase if this 388 would become 389. Right, so in that case you see the difference is increasing, so difference is 5 now, so correct answer is 388 Hz. Okay, so 388 Hz is the correct answer in this case. Now question number 7, a stress string is vibrating in the second overtone, then the number of nodes and antinodes between the ends of the string are respectively. So second overtone means you have a stress string, so this is the first. This is the second. Now let's see, it is overtone or not. What is the length is L, wavelength say lambda naught. So lambda naught equals to L, so V equals to F lambda, or F naught equals to V by lambda naught, that is V by L naught. It is good to check once. Okay, here it is lambda 1 by 2, lambda 1 by 2, so L equals to lambda 1 by 2 plus lambda 1 by 2, it is lambda 1. Okay, I also even forgot the exact formulas, exact relationship, but I can formulate it any time I want. So V is equal to F1 lambda 1, so here F1 equals to V by lambda 1. It is lambda, in this case is lambda by 2, sorry, so lambda by 2, so it is 2L. Lambda naught equals to 2L, so here it will be 2L, okay, V by 2L, here it will be V by L, or 2 times V by 2L, or 2 times F naught. So yes, this is a overtone. Overtone means the frequency is doubled, right? So overtone means frequency is doubled. That means how many nodes and how many antinodes respectively, right? So how many nodes? 1 node, 2 node, 3 nodes. So there are 3 nodes. There is 1 antinode, there is second antinode. So 2 antinodes, 3 nodes and 2 antinodes are the answer. Okay, you can draw this, you can understand. Okay, I just checked it. Yes, this is the second overtone, this is the first overtone, sorry, this is the first overtone, so this is the answer. Second overtone means you have to go to higher order and you have to find out what will be the second order. Now, a pipe of 30 centimeter long and open at both ends produces harmonics. Which harmonic mode of the pipe resonates at 1.1 kilohertz source? Given the speed of sound in air is 330 meter per second. Okay, so a pipe of 30 centimeter long, open at both ends. So first let us check what are all the possible cases. So first we'll find the fundamental frequency, okay, and in case of both sided open-ended, all the frequencies are possible, okay. So first we will check what is the frequency of the fundamental frequency, okay. So this is lambda naught by 4, it is also lambda. This is same as the previous problem, only the values are different. So in this case the length of the pipe, say L, okay, so L is basically lambda naught by 4 plus lambda naught by 4, that is lambda naught by 2. So lambda naught is equal to 2L. So frequency naught is equals to V by 2L. Okay, so this is the fundamental frequency, right? Now fundamental frequency, let's calculate fundamental frequency. So F naught equals to V is 330 meter per second, and what is the length? Length is 30 centimeter. Okay, so 2 times 30 centimeter means 30 times 10 to the power of minus 2. I always say use this without any confusion. So 0 0 cancels, 3 3 cancels, 11, okay. So 11 by 2, that is 5.5 times 10 to the power of 2 hertz, okay, 10 to the power of 2 hertz. Or you can say this is equals to, so fundamental frequency is equals to 0.55 times 10 to the power of 3 hertz, or 0.55 kilohertz. Okay, so this is the fundamental frequency. So they have asked you what who will resonate with this. So who will resonate with this? Let's see. 1.1 is the given frequency, divided by fundamental frequency should be the number of 1.1 divided by 0.55. So this is the 2. So second harmonic will resonate. Okay, second harmonics will resonate with this. Okay, now last question. A metallic wire of 1 meter length has a mass of 10 times 10 to the power of minus 3 kilograms. If a tension of 100 Newton is applied to the wire, what is the speed of transverse wave? Okay, now this question is no longer part of your syllabus, speed of sound in a medium. So unfortunately this question I am not going to answer. We have reached the end of the lecture, and as you see we are already completed all the lectures. Some bonus lectures, how to master physics, is there, okay, and all the playlist link is given in the description below. Don't miss out on all the lectures of KCET. If you have not watched, don't forget, I will be back with some more videos on KCET, some chapter revision, some most difficult questions of KCET. So don't go anywhere, stay with the channel and join our WhatsApp channel. The link is given in the description, and don't forget to like, share and subscribe this video with your friends. I'll be back soon. Till then, bye.